What is up, boys and girls? Another episode of the Blocker series, the complete blockchain from scratch. And in the previous episode, let's do a make run real quick. We basically we have our peer discovery, right? Peer discovery, we can connect with one, and we're basically going to connect with everybody. We're going to discover the whole shebang, right? That's perfectly fine. So first thing I want to do is basically, we have sleep here, time seconds here. We could sleep a second here. That's fine. Let's test again because I think it's going to be boom, boom, boom. Yes, that's good. All right, so I think it's time to basically start progressing to creating blocks. Of course, if you want to create blocks, we're going to do that with a proof of stake. Actually, I was also thinking maybe we should do a proof of work. Some simple proof of work, but hey, not quite sure. I think proof of stake could be good because proof of work, I think it's an old ancient thing. Probably nobody is ever going to do anymore, right? Due to reasons. So basically, we're going to progress towards that. But first of all, what we need to do is also some validation. It's very important. But first, we're going to broadcast transactions. Then we're going to basically, you will see, we're going to first broadcast transactions. That's going to be a good thing. Okay, so we have this make transaction thing, and we transformed that into a test gRPC dial stuff, so we don't need it anymore. Well, we need the dial because we're gonna basically send a transaction. Normally, if you wanna send a transaction, we're gonna do that with our JSON API. We also need to build. It's actually pretty easy, but because we have gRPC, we could also perfectly just connect with a gRPC client to some of the node and broadcast push a transaction to it, and then it can validate, that node can validate that transaction, and it can broadcast that to its known peers. So I think that's a good approach. So basically what we're going to do here is this version. We're going to make this a TX, and we're going to say it's going to be a proto transaction. And we have inputs, right? We have inputs. Let's open up here, proto, so we can see this here. This is our transaction. Inputs, outputs. So we're going to say the inputs is going to be a slice of proto TX input, and we're going to do the same thing with our outputs, TX output. Just like that. We're going to basically make a simple transaction that's basically not valid, but we're going to put some numbers, some values into it just for the sake of, right? And of course, if we're going to start validating that stuff, we're going to make it clean and mean. So we're going to say version is going to be 1. We're going to say TX inputs. Actually, we're going to... Let's change this to, I think it's handle transaction. Yes, context to 2, and then this TX is going to be all fine. So TX inputs, we're going to have one input for now, and it's going to be the pref TX hash. I don't know. So we're going to say util, because we're not going to validate right now. So we're going to say random hash. Then we're going to say the pref output index is going to be 0. The public key is going to be, let's make a private key actually here. Pref key is going to be crypto. Generate a private key, that's fine. And then we're going to say pref key, not bytes. We're going to say pref key, public bytes, that's fine. And then we need the signature, which we are going to leave open. The same thing for outputs. We're going to say this, and we're going to give it an amount. Let's say 99 or something, 99 problems. And yeah. And we need an address, right? So we're going to say address. We're going to send it to ourselves just for the sake of. We're going to say pref key public. What's going on here? Pref key public address. Is that a thing? Okay. Caps, non-caps. That should be good, right? Pref key public address, is that a thing? What's going on here? Public address bytes, that's the thing. Yeah. All right. And then this one, boom. So we have our transaction here, and then we're going to send that stuff. So basically what we're going to do is, we're going to sleep a second. Time second here. And then we're going to say make transaction. Boom, that's the thing, right? So if we do this, let me see what's going on. Boom. So we see received TX from this node. So that's good. So we are sending a transaction to 3000, but if we send a transaction to 3000 to one of our nodes, we actually need to receive the transaction to the whole network. Let me grab coffee, which for some reason I put it on the other side of the table. And caffeine needs to be very close by, right? All right, so yes. So how are we going to do that? Well, we're going to open up our node real quick. Let's close this. We have let's do this mouse pointer away. We are going to, first of all, handle transaction. Where is this thing? Here. Hop. So what we're going to say here, we're going to make a nice logger. We're going to say n logger. We're going to say debug w. And we're going to say received tx from received tx. Received tx, and we're going to say from is going to be peer adder. We're going to say that the hash is going to be the hash, right? So how are we going to calculate the hash? We're going to say hash is going to be hex encode to string. So we have a nice hex representation, and there's going to be types hash transaction of this tx, right? That's it, what it's going to be. So that's fine. We're going to delete this. Cool. So let's try it again real quick. Make a run to see if we have a nice representation here. Hex representation. Second. Boom. All right, cool. So we received a transaction from this dude, and this is the hash. This is the hash. Perfectly fine. We are blocking, boys and girls. Okay, cool. The next thing we're going to do is make a broadcast. So everybody is going to have the same thing. So what we're going to do is, I'm going to make a function here. We're going to say func and node broadcast. The thing is, of course, because we don't have the concept of messages, like in my previous blockchain example, we don't have the concept of messages. So we have the concept of prototypes. So we need to say here, if you want to broadcast something, we're going to say a message, and that's going to be an any type. And we're going to make it an error. And what we're going to do here is we're going to say for client maybe, or peer actually. Let's do peer in range and peers. We're going to say underscore if underscore r, because it's handle transaction, and we have this, we don't return anything, right? We return an ACK, an empty type. So we're gonna, what's going on with this cell phone? It's ringing. We're gonna say if add is gonna be n handle transaction context. Let's do a background here, and we're gonna say actually wait. So because we have an any type here, we could do something like this. Switch. Because we're gonna broadcast blocks also, and we don't wanna make too much of the same logic, right? Don't repeat yourself, at least don't try to. So we're gonna say it's gonna be switch. We already did it. V, MSG, type. Yes, and we're gonna say case. If it's a pointer to a proto transaction, we're gonna do. Wait, what am I doing here? What's going on here? Let's delete this real quick. So we're gonna loop here, we're gonna switch here, we're gonna do this. Switch V, case transaction. We're gonna say for underscore, no, not for, underscore R is gonna be n handle transaction. Again, this context, background or to do, it doesn't really matter because we're not going to use it. We're going to say V if R. It's not n handle transaction, it's going to be peer handle transaction, right? If the error is not null, we're going to basically return the error. And in this case, we're going to return null. Is that a thing? Yes, that's a thing. Broadcast, cool. Because we need to do peer, right? So we're gonna loop through all the peers that are basically in our connection map, in our client map, basically, where we're keeping these proto clients, right? And for each guy we find, we're going to basically call the remote procedure, the remote call, and it's going to be the handle transaction, right? So he's going to handle the same way like we handle it. Which basically means that he is going to broadcast it again, and probably again to us, right? But that's no problem. That's no problem. We're going to fix that. So that's broadcast. So what's going to happen in handle transaction is we're going to do this. Then we're going to say, we're going to make it in a go routine loop, right? So we're going to say go func if at, because I want to handle the error here, because if we just do go broadcast, we will never see the error, right? So we're going to say n broadcast what's going on here, this tx, right? And if the error is not nil, we're going to basically say n logger. Can we do error w? Yeah, we can. We're going to say broadcast error, something like that, and I'm going to say add, it's going to be this guy, something like that. Okay, cool. So this should work, right? So let's do it, but you can see we're going to have an issue. We're going to have an issue, but we're going to fix it. You see, boom, everybody is basically they are keep broadcasting this stuff, right? And that's because they don't know if they already seen this transaction, so they keep broadcasting it to everyone, and then they're gonna broadcast it, and it's gonna be a never-ending story, right? And that's because we don't have a mempool. So we're gonna make a mempool real quick. Actually, we should make the mempool in another file, but for now, we're gonna make the mempool here to keep it easy. So we're gonna say mempool strict. Right, so basically what is a mempool, because probably a lot of you guys already have heard of a mempool. Well, a mempool is basically just a pool in memory of known transactions, right? So if, for example, if we're playing a game, right, and we're playing a numbers game, and, well, it's going to be a stupid analogy, but hey. So if the thing is, if I'm telling you numbers, and we need to go from 1 to 10, but you cannot have any duplicates, what you're going to do, you're going to remember, right? So I'm going to say 1, and you're going to say, okay, you already said 1, and you're going to remember that. If I say 1 again, you know we already have 1, so you're going to just forget about this. If I say 2, you're going to check, oh, he didn't say 2, I didn't know about 2, so I'm going to get 2, and I'm going to remember it, so I have 1, 2. And then I'm going to say 6. 6, you never heard of 6, so you're going to remember 6. So you have 1, 2, 6. And I'm going to say 2 again, but you already know 2, so you're going to just do nothing. You know what I mean? That's the same thing. So the mempool is basically each time I'm sending a transaction, I'm going to remember that transaction in my memory. So the next time some other dude is sending me the same transaction, because it's a peer-to-peer gossip protocol, so it could be that there is some delay, right? That I already received transaction from Bob, his note, but then Alice, which is in Ouagadougou, right? That transaction broadcasts it takes a longer round trip, for example. I already have that transaction from Bob, so I don't need to have the same from Alice. I can just drop it, right? That's what we're going to do. Normally, in an ideal situation, the mempool is going to be a sorted thing, basically. But hey, we're going to make a map for now, and we're probably going to change it up or something, or do something else with it, because depends on how performant your node needs to be. We could use something like binary trees and everything to sort that stuff. But hey, I don't want to make it too complex. We will see. We will see. It's just a structure. We can actually remove it and plug something else in later on if we really want, right? All right. So let's do something like txx is going to be a map of it's going to be a map of strings, because we're going to keep the hash, and we're going to make a pointer to a proto transaction here. I'm going to say here func new mempool, which is going to basically, what's going on here, a pointer to a mempool. Mempool, just like that. You're going to say return and mempool, and we're going to say txx is going to be make me a map of string to pointers to proto transaction. What you could also do is make some kind of a validation thing, like a confirmation thing each time somebody is sending a transaction, and you validate that, and you can increment a counter to see how many people already have validated that and broadcasted that, something like that. But that's all fine-tuned tricks. The question is, how deep do we need to go? That's a question I'm always asking my girlfriend also. How deep do we need to go in this? All right, so new mempool is fine, Then we're going to say here, actually, to be honest, this mempool needs to have a mutex. But like I said, I want to see how far we can get without mutexes, because mutexes are slow, right? Mempool. There's going to be a pointer to a mempool here. It's going to be a pointer to this beautiful mempool. Boom. And then we're going to say here that the mempool is going to be a new mempool, right? And like I said, mempool, you can make a mempool structure as complex as you want, right? We're going to make it simple because we are learning here. And then after all, make it work, make it better, make it faster. That's the circle of success. Trust me. All right, so we have this mempool. So what we're gonna wait. So what we're gonna do is we're gonna add some functionality to this mempool. Let's do it here. So we're gonna say first of all, we're gonna say pool. It's gonna be a mempool. We're gonna say has. Actually, we're gonna make it has, and we're gonna say tx, which is gonna be a proto transaction. We're gonna say bool, and we're gonna say here okay. It's gonna be pool. We need to hash this thing. I'm gonna say hex encode to string like this, and we're gonna say types hash transaction tx, and then we're gonna say pool hash just like that. It's gonna be pool txx, by the way, just like that, and then we're gonna return this okay. Right. So what's happening here? We're basically gonna make the hex representation string from the transaction hash. We're going to hash it. We're going to make it a nice hex string, so we can, because we cannot use bytes as a key in a map in Go. So we're going to use a string, and then we're going to just basically check if we already have that, yes or no, and if we're going to return that value, right? Do we have it already in our mempool, yes or no? The next thing we're going to do is a very simple function. Also, actually, let's retype it out. It doesn't matter. So we're going to say pool mempool add. We're going to add, and we're going to say tx is going to be a proto transaction. And what we're going to do is basically do the same thing. Actually, we're first going to check this. To be sure, we're going to say if pool has tx, right? If we already have this boy, this bad boy, we're just going to return here an early return. I like that. Early return. Otherwise, we're going to say, let's doing this. We're going to make a hash of this thing, and then we're going to say pool txx hash is tx. Right? Yes, I think that's cool. So, right. The next thing we're going to do, because remember this infinite loop. Well, we're going to fix that, right? So we have handle transactions. So what we're going to do here is, before we actually going to broadcast, we're first going to check, right? We're going to say something like if n mempool has this tx. If we don't have this, then we're going to boot this up, right? If we don't have the transaction, we're going to say n mempool. What's going on here? N mempool add this tricks, right? Because we actually do a double check. Yeah, because we check as has here. I think we can do some cool trick, to be honest. Because we're double checking with has, right? So what we're going to do is, we're going to do add, something like that. And we could do bool, right? So we could say return false. And in this case, we're going to return true, right? This happen. What if we're going to say add, and it basically going to do is going to check if we already have it. If we already have it, we're going to return false because we didn't add it. On the other hand, if we don't have it, we're going to add it and we're going to return true because we added it. If that makes sense. So that basically allows us to do a little skip in checks. Where are we actually here? Handle transaction. Let me search it. and reverse it. Handle transaction. What's going on? Well, yeah. The problem is if you use Vim, you can do this search without capital letters. But in VS Code, I still need to figure out how I need to do that. So we're gonna basically do this, right? We're gonna say if and mempool add, right? We're gonna add this thing, and if we added it, then we're gonna broadcast it, right? So this basically makes that if we do a make run, I hope everything is fine. Yeah, so the problem right now is, you see, it's working. We are not spinning up, but we receive a lot of this bullshit. And that's because we actually log this thing. So of course, people are going to try to send it to us because they don't know that we already have it. So what we're going to do is we're going to do this. Right, and if you do make run, I need to sneeze, it's going to be nasty. I can feel it already. Oh man, I'm so sorry. All right, you can see, beautiful, right? So everybody is basically adding this beautiful transaction. Actually, what we're going to do here is, oh man, the sneeze feels so good. So from, do we actually care from who we received it? Yeah, maybe. So we're going to say here, we is basically analyst and adder. So it's always interesting to put up a we, so we know who the node is that actually yelling at us in the terminal. Right, so you see, perfectly fine. 3, 4, 5, we all have the TX. Everybody in the network have it. It's so cool, right? I love to do this stuff, man. It's amazing. Of course, things are going to get complicated and we might regret it, but hey, that's why we start with filling so much dopamine that we are basically completely numb. All right, cool. So now we can add in transactions, that's fine. So you could say, who's making transactions? Well, we, the normal people, right? People are going to make transactions by posting it in wallets, by posting it by wallets through JSON API, because yeah, that's how it goes. And we post that just to a node, and that node going to validate it, it's going to broadcast it, put it into the mempool, and then we have validators, which we're going to make now. Validators, normally in a proof of work, basically, the first that can solve the puzzle will be able to forge the block and get the rewards, right? In our case, in a proof of stake, we're going to have a consensus mechanism that's basically gonna determine who, for this round, is going to forge a block. Right, because we cannot all forge a block, right? If we are, let's say we are in a room with 5 people, and only the leader can do something, only the leader can press the red button to escape in an escape room. Only the leader can do that, but who is the leader? Is everybody going directly to this button? We're gonna clap each other's cheeks because you know what, you can't. So there needs to be a leader. So how this room of 5 people, how do you come to a leader? Well, it's by a consensus, right? You're gonna discuss with each other, right? Yeah, but I'm stronger. Yeah, but I'm smarter. Yeah, but I smell good, you know? So it's their consensus and they're gossiping. And at a certain point of time, they do a vote. And then, yeah, I don't know, somebody wins and he can press the button. That's the same thing here. That node can forge a block, right? If that makes sense. Man, it's so crazy that I came up with these things on the fly. It's insane. All right, so... okay, so a lot of stuff needs to be done, right? Don't get me wrong, we also need to do validation. We're going to do that later on. First of all, we're going to make things kind of work, and then we're going to validate the shebang. So what we're going to do is, first of all, we need to have, look at this. What we're going to do is this. Actually, let's open up main real quick. What I'm going to do here is I'm going to make this a loop. I'm going to make this a for loop. We're going to sleep each, I don't know, 2 seconds or something. Times second. Times 2, right? And then we're going to make a transaction. That's fine, we don't need this. So we have something right now that basically is going to keep sending transactions each 2 seconds. So if we have a block time of 5, we're going to have 2 transactions in each block, right? That makes sense. So we receive a transaction, boom, receive a transaction, boom, receive transactions. And you can see it's all different transactions, right? Because we randomize them. That's fine. So we're chilling, right? So now what we're going to do is basically, let's delete this real quick. So we are going to make a validator loop, right? Maybe here, func and node. We're going to call this can make it small, validator loop. And that's basically a loop, a for loop, right? We're going to make a ticker, and we're going to say time, new, ticker. It's going to be time, second, times, let's do this, const, block time, is going to be time, second, time, 5. Let's make it 5 seconds. We're going to see that because it's all going to depend also on the consensus algorithm, right? And actually, to be honest, I'm thinking maybe we should do a proof of work. I don't know. Guys, let me know what you want to see. Let me know what you want to see, because proof of work, I never did that before. But hey, let me know in the comments what you want to see in the next episode. So time new ticker, time second. We're gonna actually change this. It's gonna be a time. No, it's gonna be a block. Default block time. Is that? We made it block time. Okay, it's fine. Doesn't matter. Block time is good. Block time is good. Block time. Boom. That's a ticker, and then we're gonna say ticker C, and then we're gonna basically force a block here, right? But for now, we're not gonna do that. We're gonna say n logger debug. Actually, this can be info w starting. What's going on here? Starting validator loop. We could do address is going to be, damn, we don't have that. Wait, first of all, how can we know for, like I said before, not everybody can basically forge a block out of the mempool, right? Because we need to have some kind of consensus. So what we're going to do now to mimic that is we're going to make a config. We're going to put a private key in a config, and the guy with the private key in his config, because he needs the private key to sign the blocks, that's going to be the validator, right? Because we have, I think, 3 nodes booting up. That's going to be the validator, just for now. So we're going to make this here, this new node. We have a node struct. We're going to say type. We're going to call this a server config. It's going to be a struct. We're going to say here, we're going to actually put everything in here. We're going to say string listen adder string validator key string. Actually, let's call it private key. String. No, it's going to be a string. It's going to be a crypto private key, just like that. And I think, yeah, that's what I thought. So we're going to do this crypto. Boom. Because it's actually default importing the default crypto package, right? We don't want that. Where are we? So I have a config, version, a listen address, and a private key. Is that all we need? Yes. So we're going to delete this, and that's fine. Then we're going to say, here a server config. We're going to embed that thing. We're going to say here that we need a CFG, which is going to be a server config, right? And then we're going to say the version, we can delete that stuff. We're going to say the server config is going to be the CFG. That's fine. And listen adder. It's going to be listen adder. Actually, this is so weird because let's refactor it later on, otherwise it's going to be nasty. So we're gonna change these things up. It's gonna be this. Where is here? And where are the other ones? Here. We could actually replace all. I know, but I don't like that because most of the time you're gonna fuck yourself. Listen, address. Yeah, I think it's good, right? So that's fine. So what's gonna happen right now is that in start here we're gonna say if the n private key, if this is not nil, right? If it's not nil, that basically means this is gonna be the validator, right? This is what we're gonna do. We're gonna go and validate the loop. That's what we're gonna do. All right. So now we could say here address is gonna be hex encode to string, and that's gonna be. Do we have a string version on this address? Let me see. Crypto keys. Hey, we have a string. That's fine. That's amazing. So what we're gonna do actually? What we could do actually here is, this is fine. So we're gonna say, starting validator loop, address. Actually, we could do a pub key, why not? That's gonna be n private key, public. And maybe we're gonna say the block time. It's gonna be n, it's gonna be block time, right? This thing, that's fine. Then we're gonna copy this, paste it in here, and we're gonna say, it actually can be a debug thing. Debug W. We're gonna say, change everywhere, creating time to create a new block. It's that's fine. Let's see what's going on here. Oh, we can't because we actually need to fill up this whole shebang into main, right? So we have all these things. The problem is, make note what we're going to say here is we're going to make a bool is validator. It's going to be a bool, right? And we're going to say here is going to be the CFG node server config. Shit, caps lock is on. That's crazy. That's nasty. So what we're going to say here is version is going to be a blocker thingy, blocker 1. Then we have a listen. We need a listen adder, which is going to be the listen adder here. The thing is, we put the listen adder in start, right? So it's we're going to refactor it a little bit. Then what do we need? The private key, right? We're going to say private key. Actually, no. What's in the server config real quick? Version, listen adder, private key. Okay, cool, it's fine. So what we're gonna do here is we're gonna say this is gonna be the CFG, but if is validator, we're gonna say that the CFG private key is gonna be. Let's create a new one for now. New generate private key. Boom, just like that. And then this, and then that. That should be it. Oh yeah, of course. Then here we're gonna say, let's make this this is a validator. This of course not, because we can only be one. False. Let's see. All right, so we're receiving these transactions, and then this guy is basically creating a new block, right? Yeah, see, it's creating blocks. That's fine. It's only one. So what we could do is, time to create a new block. We could say txlen of len tx, and that's going to be something like n mempool len n mempool tx, something like that. What we also need to do is basically each time we create a block, we need to delete the transactions from the mempool, right? So I think we need to make sure that we have a syncing mechanism so we don't have data race conditions in that thing. Of course, right now it's gonna be 2, 4, 6 transactions, right? Because we don't clear them, right? That's for the next episode, I guess. Maybe what we could do is I think we need a syncing mechanism. So because what's going to happen here in validator loop, what we're going to do here is basically do something like we can't, right? It's not true. It's going to be hash tx. What's going on here? We're going to say delete. Is it hash first? No, it's not true. It's gonna be this, right? Hash. That's what's gonna be, and this is gonna be the transaction. It's gonna be out of it. Actually, we can loop it like that. Something like that. Of course, this is actually not safe. This is unsafe code. This is legit unsafe, guys. So, but I'm just doing it for the sake of demonstration. What is this? All right, what's going on? So we're deleting this stuff, right? So it's going to be boom. We have back again 2 transactions, and we're going to create a block, right? Then we're going to clear it again. Yeah, so it's fine. Something like that. And of course, each time we're going to create one, we're gonna basically put the transaction in and add it to the blockchain, increase the height, and that's how we're going to have these nice blockchain. So I think it's for the next episode, to be honest. We're going to make this a little bit safe. I think we're going to make the mempool safe. We're going to add blocks to the blockchain, and then I think we can start doing some validation with these UTXO stuff, do some more information, teach you guys some more information about that. And yeah, I think, yeah, it's good. It's all fine. So I see you in the next lesson, next episode. Bye-bye. And I need to find a way to close my OBS. Bye-bye.